So this warm-up is to go over what we've done in this unit so far. So kind of go back to that central limit theorem and then talk about our confidence intervals for proportions that we talked about last class. So here are the formulas that we kind of need that we talked about in our last class. These will be provided for you on quizzes and tests, so I don't expect that you memorize them. However, you should know how to use them and what they're used for. So first, let's talk about the confidence interval that we ran last class. So in a study of 200 randomly selected Southwest airline flights, 67% of the flights left on time, determine a 95% confidence interval. So because we're working with a percent, we know we're working with our one prop Z intervals. So the values and things that we need are N value. We're looking at 200 flights, so our N value is 200. I don't know X at this point, but I do know that my proportion is 0.67. My point estimate is 0.67. We can then find X by doing 200 times 0.67, which would give us 134. So our X value is 134. And then we're looking for a 95% confidence interval. That's kind of all the information that we'll need to be able to run our confidence test. So then we need to check these three conditions. So first, is it a simple random sample? It says that they were randomly selected. So we're going to assume that's a simple random sample. Then we need to check that N times P is greater than or equal to 10, and that N times 1 minus P is greater than or equal to 10. So if I do 200 times 0.67, that gives me 134. That's definitely greater than or equal to 10. And then if I do 200 times 1 minus 0.67, I get 66, which is also greater than or equal to 10. So that condition is met. And then our last one is just if I take my N value, I want to make sure that it's a good size. So if I look at 200 and I add a 0 to it, is it reasonable to assume that there are more or have been more than 2,000 Southwest airline flights that we could have used for this study? And our answer would be yes. So our conditions are checked. We can go ahead and move forward with our confidence interval. So to do that, remember we hit the stat button on our calculator, go over to test, and then we're looking for our one prop Z interval. So you got to be careful that you're picking the right one. We're not looking at a Z test. We're looking for a Z interval. So for most of us, that should be the letter A on our calculator. So then just these values that we already know, we're going to type into our calculator. So our X was 134. Our N value was 200. And then I want to be 95% confident. So when I calculate that, I get 0.60483 to 0.73517. All right, so that's the confidence interval that we need. And then we can go ahead and interpret our results. Remember, we interpret our results. It's basically a formula for what we write. We always start with I am and then have whatever percentage we used. So 95% confident that the interval, and this is, we'll use whatever values we got here, contains the true proportion of flights that left on time. We always want to tie this back to the problem that we're solving, put some context to it, so that someone doesn't necessarily have to read the problem to know what our results are. So if Southwest Airlines claims that 79.4% of all their flights leave for their destination on time, does our data support this claim? Why or why not? So we would want to see, is that percentage within our interval? If we look, 79.4% is not. So no, our data does not support. 79.4% is well outside our interval. Yeah, it's not even close to the values that we found. So we could not support their claim based off of what we found. So then the last part says, using the same data from question 2, 79.4 is the population parameter. If I want to conduct a new study, how many flights would I need to examine in order to have a 95% confidence interval and get a margin of error of less than 5%? So we're looking for our sample size now. So that means if we look over here in our formulas, we're trying to find n. So then the difference between these two formulas is, do we know a point estimate or do we not know a point estimate? In this case, it's telling us to use 79.4. So that means we're going to go ahead and use this formula here. So n equals our z star squared, or our critical value squared, times p times q over e squared. So because I want to be 95% confident, that means z is 1.96. That's in our table at the top as well, right? If I want to be 95% confident, my critical value is 1.96. So I have 1.96 squared. My population parameter is 79.4%, which we'll write as 0.794. And then remember, Q is just 1 minus P. So if I calculate 1 minus 0.794, I have 0.206 as my Q value. And then our margin of error is less than 5%. So again, we also turn that into a decimal. So 0.05 squared. So once I type this into my calculator and solve, that will tell me the n value that I'm looking for. So 1.6 squared times 0.794 times 0.206 divided by 0.05 squared. So we get 251.3. Remember, we always have to round up here. I can't look at 0.3 of a flight. So in order to have enough data, I have to have more than 251.3. So I'd have to have 251 flights in my sample to confirm that my population is 79, if 79.4 is the correct population parameter. Okay, so that was kind of our review, a quick review of our confidence intervals from last class. So then if we turn our paper over, we have a little bit more practice on our central limit theorem. So it says the average cost to travel with Southwest Airlines is $142 with a standard deviation of 50. What is the probability that an individual will pay more than $150? So we're looking at our normal distribution curve. Right, our mean is 142, and I want to know the probability that someone pays over 150. So I'm looking for this shaded region here. So because I'm looking for an individual, I'm just looking for one person. This is our review of Unit 3. I'm just doing a normal CDF. My lower bound is that 150. My upper bound, I want all values to the end of this graph, so I use 1e to the 99. My mean is 142 and my standard deviation is 50. So I can go ahead and calculate that. I hit second vars. I go to normal CDF. My lower bound is 150. My upper bound is 1e to the 99. My mean is 142 and my standard deviation is 50. So when I calculate that, I get 0.4309. That's my probability. So then part B asks, what's the probability that 20 passengers will pay more than $150? So in this case, I'm looking at n equals 20. So our central limit theorem told us that our mean is not going to change, but our standard deviation is. So we're still looking for the same results here. We're still doing our normal distribution, where our lower bound is still 150, our upper bound is still 1e to the 99. My mean does not change. Yeah, we talked about in our central limit theorem that the population mean and the sample mean stay the same, but it's my standard deviation that I'm going to divide by the square root of n. So in this case, I'm going to divide by the square root of 20 in order to calculate. So if I go up here, I'm using all the same information. I'm just changing that last number to be 50 divided by the square root of 20. And when I do that, I end up with 0.2371 as my percentage. All right. So then the last question in our warm-up, what price does the bottom 10% pay for flights? So if we think about our normal curve, I'm trying to figure out at 10%, so somewhere over here, what are these people paying? What's this kind of value that represents 10%? What did 10% pay for that? Or what is that value that 10%ers paying for? So we did this in unit 3. This is our NV norm. This is finding whatever value this is. So to do that, we need to know, right, if I go to second vars, I'm going to go to this NV norm. The area that I want is the bottom 10%, so 0.1. My mean is still 142. My standard deviation is still 50. And then if your calculator allows, if we want the left end of this graph, if your calculator doesn't ask you, it's always assuming the left end anyways. So because we're looking for that, there's nothing you need to change. So then we'll go ahead and hit paste. We were doing 0.1 of 142. So then that means that value here that would represent the 10% mark would be $77.92. So that bottom 10% is paying $78 for a flight. All right, so hopefully that was a good warm-up of what we've done over the last 2 days before we move on to our notes.